Hello, students, and welcome to our lesson today. We're going to solve systems of inequality applications today. So let's get started. Our do now will be about strong emotions. We'll be responding to a prompt about that, and we're going to respond, remember, in class notebook. Today, we will solve a system of inequality applications. We'll do 5 of those. Our essential question, of course, then what are some real world problems that can be solved with a system of inequalities, and how can I set up those problems? That's a very crucial part of what we're going to be doing today. Remember, your participation credit comes from completing your do now, completing your work, and you have 6 problems. I believe it's 6 or might be 5 problems today, showing every step of the way. Turn in photos of your work in assignments and complete the exit ticket. For homework, it's homework 510, system inequalities. There are 5 problems, and we want you to show all your work. Remember some important notes. Having your camera on shows that you are interested in and that you're participating in the lesson, and it helps your participation, helps you to do better. You earn participation credit by completing your lesson and turning in photos of your work on time, and that's in assignments. Keep the objective and the essential question in mind as you work. That'll help you focus on what it is you need to take away from that lesson. Attend after school help if you need it. And please remember, we complete our do now on our exit ticket in teams, and that counts. It's part of your lesson assignment. So let's start. There's our exit ticket. We'll come back to that. Let's start with our do now. So if you have an interesting do now today, it says emotions matter. Emotions affect what we say, do, and think, so it is vital, meaning it is very important, to manage them so we can make healthy decisions in our daily lives. Now, a strong emotion such as fear can emotionally paralyze us, okay, can really get us frozen and stuck in place. Have strong emotions ever kept you from moving forward? I know that when I'm really concerned that I do something good enough, that I do something well, I can get kind of paralyzed with fear, and it stops me from getting the job done. It enables me to get distracted. I focus on something else rather than the project I should be doing, and it's the very thing I'm afraid of that I should be working on. So I'm sure you have strong thoughts about that. So answer that here, please. And then let's think about all those coping strategies that we talked about this year to help you with those fears or other strong emotions. If your strong emotion is anger, then we're going to learn some self-love and how to stay calm. So let's get started with our lesson. I'm hoping the strong emotion you have here is let's get it done and let's focus. All right, so we've got systems of inequality word problems here. Except for the graphings, much in the fact that they're inequalities, much of this, we've done things like this before. We will start by identifying these variables. So suppose we buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound, and cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. So we're going to let X equal flour. We're going to let Y equal the cornmeal. Okay, so flour is our X, cornmeal is our Y. So what are the 2 things we have going on here? We've got the cost of flour and the cost of cornmeal. Flour is $1.50 per pound, cornmeal is $2.50 a pound. You want to spend less than $25. Okay, so we've got less than. Now, if it says less than 25, but you need at least 6 pounds. If you want to spend less than $25, You have to decide is it okay to spend $25? Is that $25 going to be okay? Same with you need at least 6 pounds. Well, is 6 pounds going to be okay? If 6 pounds is okay, then we're going to have greater than or equal to. But if it must be more than 6 pounds, it's going to be greater than. So you need to tease that out first when you look at these. I'm going to say that I think it should be less than on the $25. Less means less. 25 is not okay. You're going to spend up to $24.99. And I'm going to say greater than with the flour, with the number of pounds that you need altogether. So these are your goals. So I've got the flour and the cornmeal. I'm going to spend less than $25. So flour is $1.50 per pound. So 1.5x plus cornmeal is $2.50 a pound. So I'll make that 2.5y is less than 25. Now, we need at least 6 pounds of this combination of flour and cornmeal so that we can make the amount of food we want to make, the number of tortillas. Maybe there's a party or something that she's planning. So the flour is in the tortilla, the x plus y must be greater than 6. So next thing we do is we graph these. We have to put them in slope-intercept form. So the first one would be y is less than negative 3/5 x plus 10. And the second equation, we just move y to the other side. Y is greater than negative x plus 6. So let's see. We notice we only have the first quadrant. We have quadrant 1 of the coordinate plane because negative quadrants would not be meaningful to this problem. We don't have negative money and we don't have negative tortillas or pounds of flour or cornmeal. So this first inequality, we need to find the y-intercept of 10, 2, 4, 6, 8, 10. There we go. We have a slope of negative 3/5, 1, 2, 3, over 1, 2, 3, 4, 5, 3, 5, 3, 1, 2, 3, 4, 5. So just roughly speaking, now we've got less than, so we'll have a dotted line. And we'll shade below the line. And then for our second inequality, let's change our color. We have a y-intercept of 6 and a slope of negative 1. That should be a dotted line. And this time we shade above the line. So here is our solution. It's a defined area. It is not an infinite solution. It's this area in here. So let's go to Desmos. Let's look at that graph. So this is our first inequality. This is 1.5x plus 2.55y is less than or equal to 25. And then here is our second inequality. And this overlapping area here, only in the first quadrant. So I'm going to move the Desmos down like that. This is our solution set. So we were asked to write 2 possible solutions for this problem. And so we could say 6 pounds of flour and 2 pounds of cornmeal. That definitely falls within the parameters of this problem. How about 8 pounds of flour and 4 pounds of cornmeal. That also falls within the problem. How about 10 pounds of flour, because the x-axis is our flour, and 2 pounds of cornmeal. Yeah, that would fit the problem. Any point within this overlapping area would be a solution to the problem. So let's write that down. We could have 6 pounds of flour and 2 pounds of cornmeal. Or we could have 8 pounds of flour. LB is the abbreviation for pound. And 4 pounds of cornmeal. And even partial parts of a pound, so portions of a pound, like a half a pound or a quarter pound, anything that would fit within this area here is a solution to this problem. So let's move on to number 2. A seafood restaurant owner orders perch and salmon. Those are 2 different kinds of fish. Perch is $4 a pound and salmon is $3 a pound. He wants to buy at least 50 pounds of fish, but cannot spend more than $20, net $240. So he can spend $240, just not more than $240. He wants to buy at least 50 pounds, so he can buy 50 pounds, but he could also buy 60 pounds or 51 pounds. So the perch is $4 a pound, so I'm going to let X be the perch, and I'm going to let Y be the salmon. I love salmon. It's so good. So at $4 a pound, the perch plus the salmon at $3 a pound, that's our Y, has to be less than or equal to $240, because that's the most this chef, the most she or he can spend for this. Maybe it's a catered party budget or something like that. Very real world problem here, students. Now, the perch and the salmon together, so that's our X plus Y, must be at least 50 pounds, I guess, to feed all the guests. So we graph this. So when you graph this, we're going to have to play around a little bit. Well, first, let's put them in both in slope-intercept form. So in slope-intercept form, that first equation would be y is less than or equal to negative 4/3 x plus 180. The second one would be y is greater than or equal to negative x plus 50. So we need to make some changes to the x and y axis. If we were to graph this by hand, we could make this the x-axis and the y-axis be 10, 20, 30, 40. So we need to think about these intervals. Again, here, 10, 20, 30, 40. Okay, and then you could graph this starting with the y-intercept and then graphing the slope. But I've made it a little easier. Let's go to Desmos, and we'll turn off the first 2. And I've got the second 2 inequalities right here. So remember, we're only looking at the first quadrant. And you can see by the intervals on Desmos, each square looks like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And then the same thing with the y-axis. But you can see the overlapping region. So I'm going to turn off the second one. This is the first inequality. The 4x plus 3y is less than or equal to 240. Here's the second one. And because we have less than or equal to, we have a solid line. So here's the second one. I'll turn off the first one so you can see the second one. And then when I turn them both on, you can see this overlapping region here satisfies the parameters of this problem. So for example, they could get 10 pounds of perch, so we'll go over to 10 on the x-axis, and 50 pounds of salmon. That would bring us right here squarely within the solution area. They could get, let's say, 30 pounds of perch and 30 pounds of salmon right here. Again, squarely within the solution area. So let's add that to our solutions. So they could get 10 pounds of perch and 50 pounds of salmon, or they could get 30 pounds of perch and 30 pounds of salmon. And that would fit the parameters of the problem. So moving on from seafood, we've got a great little, we'll get to the knitting problem in a second. We've got a problem with CDs, and I start to wonder every year as we do this, when am I going to get to the point where I have students in my class who don't know what CDs are? And I hope you still know what CDs are. This is a good problem. The We Sell CDs website plans to purchase ads. Now, if you don't know what CDs are, pretend this is anything else. It doesn't matter what the product is. What matters is they're selling ads in a local newspaper to advertise their site. Their operating budget, so the budget that they can use for buying these ads, will allow them to spend at most, that doesn't mean more than, that means including but not more than, $3,000 on the advertising adventure. An ad will cost $30 if it appears in the weekday and $50 if it appears in the weekend edition. They also plan to run at least 50 ads. So this is at least 50, that's a greater than. This is at most 3,000, so that will be less than or equal to. And also let's define our variables. So X would be the weekday and Y would equal the weekend. And I guess more people read the newspaper on the weekend, and that's why it costs more to run an ad on the weekend. So, and this, even if it's not a paper edition, an online edition, this is probably still the case. So let's set up our problem. So we've got weekday ads at $30, 30x, plus weekend ads at $50, must be less than or equal to 3,000 because that's their budget. So, and they want to run at least 20 ads. So X plus Y must be greater than or equal to 20. So they want to run at least 20. 20 is okay. I think I may have misspoke earlier. 20 is okay. It's at least 20. So how do we graph this? Well, let's put it in a slope-intercept form first. Our first equation will be y is less than or equal to negative 3/5 x plus 60. Our second equation, to put it in slope-intercept form, y is greater than equal to negative x plus 20. So we can see immediately we're probably going to need to do something like use larger intervals of maybe 10 in order to graph this by hand. But I did go ahead and graph it with Desmos. So let's turn off our prior problem. Here's the first inequality, that 30x plus 50y is less than or equal to 3,000. And then our second inequality, x plus y, is greater than or equal to 20 because they want to buy at least 20 ads. So the overlapping region looks like this. There's the solution. It's a finite solution. Our solution has to fall within this shaded area that comprises the overlapping region from both inequalities. So if we look for solutions to write two possible solutions, anything in this overlapping area in the first quadrant, that's the only quadrant that works for this problem. We can't buy negative ads, well, in a sense, but mathematically speaking, we cannot buy negative ads. So we need to find something in this solution area. So we could say that 20 weekday ads and 10 weekend ads or 20 weekday ads and 30 weekend ads falls within the parameters of their problem. We could say that 50 weekday ads and 10 weekend ads or 50 weekday ads and even 20 weekend ads all falls within the parameters. So let's write that on our paper. We could say 20 weekday and let's say 30 weekend. Or we could say 50 weekday and 10 weekend would satisfy the parameters of this problem. So let's move on. The next problem is about knitting. We have a knitter in our family, a couple of knitters that do a lot of that beautiful things they knit, especially for children. So Mary, my friend that knits, her name is Susan, and I have another friend named Beth. In fact, Beth owns a yarn store in Westport. So Mary knits scarves and sweaters to sell. So she really needs to understand her numbers. This is business math, folks. I mean, you'll use it in science and in engineering, but I got to tell you, in business, you need to know how much money you're making. And one of the ways you figure that out is by knowing how long it takes you to make something. So scarves take 2 hours to knit, and sweaters take 10 hours. So Mary would like to spend no more than 40 hours a week knitting. So this is going to be her business, but she doesn't want to do it more than 40 hours a week. But she does want to knit at least 5 items per week. So what combination of scarves and sweaters can she knit so that she's not working more than 40 hours and that she has at least 5 things to sell? So we're going to let X will be our scarves, and Y will be our sweaters. So 2 hours to make a scarf, 2x plus 10 hours to knit a sweater, must be less than or equal to 40. She does not want to work more than 40 hours a week. She also wants to have at least 5, x plus y must be greater than or equal to 5 items to sell. So let's put those in slope-intercept form. The first one will be y is less than or equal to negative 1/5 x plus 4. And the second inequality will be y is greater than or equal to negative x plus 5. So you see, we just moved x to the other side of the equation of the inequality, and then it becomes negative. So if we're going to graph the first inequality, we look for the y-intercept of 4, and we have a slope of negative 1 over 5. So 1 over 5, a gentle slope. And we'll graph that with a solid line. And we would graph below the line because it says it's less than or equal to. So now for the second inequality, we have a y-intercept of 5 and a slope of negative 1. Solid line. And here's our solution area right in here. It's kind of a triangular shaped space. And any combination that falls within that area of scarves and sweaters would work. And let's take a look at that more clearly on Desmos. So here's our 2x plus 10y is less than or equal to 40. Again, remember, we're only interested in the first quadrant where x and y are both positive. And let's turn that off. We'll look at the second inequality. There's our x plus y is greater than 5, shading above the line. When we put them together, we have this triangular area that indicates Mary's profit. So she could make 6 scarves and 2 sweaters, and that would be within the solution area. She could make 3 scarves and 3 sweaters, and that would fall within her solution area, right at the edge of it. She could make 10 scarves all the way up here and 1 sweater, and she would just be within, sorry, where's my 10? There it is. 10 scarves and 1 sweater right here, and that would be within her solution area. So in this triangular shaped solution area is the combination of sweaters and scarves that Mary can make in order to achieve her goal of working no more than 40 hours a week and producing at least 5 items. So 2 possible solutions, we could have 3 scarves and 3 sweaters, or we could have 10 scarves and 1 sweater. But there are other combinations that would work as well. And also note, with a problem like this, where we're talking scarves and sweaters, we're talking about whole numbers only. So the solution, you're not going to have 1.5 scarves and 2.5 sweaters. That doesn't make sense for the problem. So the only solutions that make sense are the whole number solutions for a problem like this. And then, let's see, 5th problem, we do have 6 problems. Okay, so the 5th problem is a clothing store, which is unfortunately for them going out of business, but for us, woohoo, there's a sale. So they're selling pants for $8.99 and shirts for $3.99. You can spend as much as $60, but you want to buy at least 2 pairs of pants. So there's a little bit of a trick to this one. So let's let X will equal pants and Y will equal shirts. So pants at, I'm going to round up. I don't think it's a big deal. I'm going to just round up to 9X plus shirts are $4. I'm going to round up to 4Y is less than or equal to 60 because they can't spend more than $60. And with these pants and these shirts, I don't have an X plus Y. All they say is they want to buy at least 2 pairs of pants. So X must be greater than or equal to 2. That's it for that. So slope intercept for this first equation, or inequality, excuse me, would be Y is less than or equal to negative 9/4 X plus 15, and X is greater than or equal to 2 is a vertical line. So if each of these are 1, 2, 3, so they're 1 unit apart, X is greater than or equal to 2 is a vertical line right here. And then we would shade to the right of the line where X is greater. For the first equation, we need a y-intercept of 15, 2, 4, 6, 8, 10, 12, 14, right there at the very top, and a slope of negative 9/4. So go down 3, 4, 5, 6, 7, 8, 9, and over 4. Then go down 9, 3, 2, 4, 6, 7. It would be about right there. I don't know if this is the best color to use. I'll make sure you guys can see it. So, and these are solid lines. They both have the equal sign with the inequality. And then in this case, you would shade below the line, and there is our solution set, the overlapping region right there. So let's take a look at Desmos. We'll turn off our last problem. And see, 9y plus 9x plus 4y is less than or equal to 60, and x is greater than or equal to 2. And there's our triangular area that's part of our solution. So, for example, we could have 3 pants, and back here, only the first quadrant is important to us. So we could have 3 pants and 3 shirts, which would work. We could have 4 pants and 1 shirt would work. Any of those solutions would work. So let's go back to our paper. So 2 possible solutions, 3 pants and 3 shirts. Or we could purchase 4 pants and 1 shirt. And there are lots of other combinations as well. So finally, our last problem. You'd like to see how many baseball and soccer games you can attend this spring. Travel time for baseball games is 2 hours and soccer games is 1 hour. You would like to spend no more than 15 hours traveling to the games, and in total, you'd like to attend at least 8 games. So this one's a little more complicated, but we're going to let x equal baseball games, and y will equal the soccer games. And let's get a brighter color for this. So we're going to write and graph a system of linear equalities. So baseball games, which are 2 hours, plus soccer games, which are 1 hour, so I just put y, must be less than or equal to 15 because you don't want to travel more than 15 hours. And the total of baseball games plus soccer games must be greater than or equal to 8 because you want to go to at least 8 games. So slope-intercept for both of those, for the first equation, y is less than or equal to negative 2x plus 15. And for the second inequality, y is greater than or equal to negative x plus 8. So let's graph that. We have a 15, a y-intercept of 15, 3, 6, 9, 12, 15, and a slope of negative 2. And those will be solid lines. In this case, we would shade below the line. And then y is greater than or equal to negative 8x plus 8. Let's find another color. So our y-intercept is 8, 2, 4, 6, 8. We have a slope of negative 1. I'll draw our solid line. Better. Okay, so here's our solution area, graphing above the line for the second line. So our solution area is right here, this triangular space right here. So we've got a couple of questions to answer. Suppose we decide on attending 4 baseball games. What is the range of soccer games that you can attend? Okay, so if we want to attend 4 baseball games, how many soccer games can you attend? Let's actually, oh, I didn't graph this one on Desmos, so we can't look at it on Desmos. But we can see that soccer games are Y. So if we're attending 4 baseball games, 1, 2, 3, 4, then we would be able to attend 1, 2, 3. We cannot count a portion, okay? We need whole numbers only. So we can attend between 4, 5, 6, 7. We can attend between 4 and 7. So let me use another color. There's our range right there. So what we would say is 4 is less than or equal to y, and y is less than or equal to 7. Now, suppose we decide on attending 9 soccer games. What's the range of baseball games we can attend? Now we're just doing the opposite, but with soccer. So let's find the soccer games. 9 soccer games. 1, 2, 3, 4, 6, 7, 8, 9 soccer games. Okay. Well, we could attend 0 baseball games because we're right on the y-axis, or we could attend 3 baseball games. So this is our range right in here. So we can attend 0, which is less than or equal to x, which is less than or equal to 3. Now, final question, is it possible to attend 6 baseball games and 4 soccer games? Well, let's see. 1, 2, 3, 4, 5, 6. That's our 6 baseball games and 1, 2, 3, 4 soccer games. Does that fall within our solution area? It does not. Okay, it's off the grid, so to speak. So we would say no, 6 comma 4 is outside the shaded region, which is our solution area. So let's go back to our exit ticket. And it says the solution to a system of linear equalities is the shaded region where both inequalities overlap. So the shaded region or area where they both overlap. And that's our solution area. So great job. You've worked hard. You need to practice these. Take a gander at that homework. Try to do your best. Remember, it's all about the practice. And if you practice, you absolutely will be great. Great job.